Hi, I'm Ryan, and today we're going to be learning about magnets. So, magnets are these things that create a strange kind of magnetic field when they're near each other. So when you see right here, that connects to each other. Now, the reason that I'm thinking of is why? Why do they do this? Well, see, that's the thing. Magnets are usually made up of tons of things that I like to call tiny magnets, which isn't the actual term for them. I just call them tiny magnets because it's easier. But pretty much what we found out is that every electron and proton inside an atom is a tiny magnet. So we all know that. Well, if you don't know, here's a little drawing I made for you. An atom is a clump of a clump of protons right here, and a bunch of electrons whizzing by them. So you might think that since all the electrons are whizzing around the proton clump in the middle, that like a current in a wire, they should produce a magnetic field, which it does. It's called an orbital magnetic field. So pretty much we know that, or if you don't know, electrons congregate in shells around the nucleus, right? So as they're going around, electrons would be alternating like so. As you can see, all of the arrows are facing in different directions, it's all jumbled, and all of this alternating cancels out its magnetic field. Whereas in something known as a half-filled shell, all of the electrons, or tiny magnets, are all going in the same direction, circling together, making a magnetic field. So that brings us to certain half-filled elements like iron, nickel, cobalt, and chromium. Now the thing is, chromium isn't magnetic. There's a reason behind that. The reason being the fact that the thing is that just because one material has magnetic atoms doesn't mean that a bunch of those atoms are going to create a magnetic solid. So when it comes to chromium, the deal is that when a bunch of atoms get together, they have two options to create a solid. One, they either align all of their tiny magnets or atoms together, known as a ferromagnetic material like this, or they would alternate, creating an anti-ferromagnetic material like so. And the atoms do whichever one requires less energy, making chromium a very, very anti-ferromagnetic solid, whereas iron is extremely magnetic. These are magnets I have here, created out of iron. Or, yes, iron. So that is how magnets pretty much work. Now, they have a lot of industrial uses. At first, they started out with bar magnets, which were pretty much bar magnets. You could probably get the picture. And people started realizing that it didn't really work because of the fact that it's just a bar, and carrying something with just a bar, might fall off. Magnets might be too weak. So we upgraded to what is known as horseshoe magnets for a lot of things. Horseshoe magnets are, like in the name, they look like a horseshoe, which is kind of an upside down U shape. If you can't really see my hand, kind of like that, like an upside down U shape, that, whatever. And what we usually do is we take the U, we hang a chain around it, or we connect it somehow, and then we get the material we're loading, put it on, and we go up. We move the material like that. So that's mostly how magnets are used in industrial uses, and yes, that's how magnets are made. That's how they work. Thanks for watching.